we looked at one from a graph. Basically, we are saying that our first derivative can tell us when we are increasing, decreasing, and it can also give us our relative mins and maxes. Today, we're going to continue with our first derivative test, but we're going to look at it with some actual equations. So, if it's called our first derivative test, what might we need? The derivative. Okay. Do I want to take the derivative as that is?
No.
No. What might I do? Simplify? How would I simplify it? Okay, well that's fine. But we do want to simplify, I agree. So notice how many things do I have on the bottom? 1. So if I take the derivative as it is right now, what rule would I have to use? Quotient. Okay. Now, do we like our quotient rule? Not really.
So much fun.
Yeah. Well, it's not bad, it's just that y'all tend to like make mistakes when we're doing it. So if I only have one thing in the bottom, can I separate this into 2 fractions?
Yes.
So x divided by x squared would become 1 over x minus 4 over x squared. And then for those, I can just use our power rule, yes? Okay. So 1 over x is technically x to the negative first. So what's the derivative of that?
1x.
Cool. Or an x squared on bottom. Yeah? Okay? So then what is my derivative of negative 4 over x squared? Right? Because my 2 is technically negative, so I would multiply by negative 2, which gives us a positive 8 over, yeah, on the bottom, yes. Okay with that. So then what's the first thing that we want to look for? Correct? What are those called? Critical points. We need to find our critical points. So what do we do?
Set a equal to 0.
Okay, did that.
And then solve.
So what would I do first?
Be smart. Do we factor something out?
I mean, you could. It's not going to be super helpful. So, like, can I add this over?
Yeah. And then you multiply those sets by x cubed, and then you get x equals 8.
Wow. Yeah.
Right.
Yeah, that makes sense.
I see.
Yes, no, maybe?
Yeah.
Some of those.
You know, I don't really want to do algebra.
Where did they go?
Is that better?
Yeah.
Okay.
I was thinking we were right.
Are we all alright with that?
Yeah.
Now that is my critical point. Okay, do I have any other values that I have to consider though?
Yeah.
What's the other thing that we said we have to consider? Where f prime of x is undefined. Is it going to be undefined anywhere? Yeah, where at? 0. So remember, this will have to be a relative min or max, okay? Because my derivative is differentiable there, so we're good to go. This second one could be a min or max, all right? We're going to include it on our interval, so 0 and 8. But then when I get to the end, we're going to have to think back to what we started with. But we'll get there in a second. Alright, so what's something that we can plug into that is before 0?
-1.
-1, sure. Now remind me, where am I plugging that into?
The derivative.
The derivative. Okay. I don't really have a factor form here. So we just have to plug into our original derivative. So, negative 1, if I put it in the bottom and square it, what are we going to have? A positive 1, but I also have a negative out front already, so this would be negative 1. Agreed? Now, if I cube it, what will that become? Negative. So then I would have negative 1 minus 8, which will be what? Negative. We're okay with that.
Yeah.
Okay, on our second one, or our second interval, what's something that we can pick there? 1, sure. So in this one, I square 1, I still get a positive, so I still have a negative up front, so I get a negative 1. But now, when I cube it, it will still be positive. So negative 1 plus a positive 8 gives us okay, and then something after 8. Sure. Or something that might be even easier than 9. Okay. Right, you can plug in 9, it's fine. I just like, if we're squaring and cubing things, right, like 10 is going to be a little bit easier to do that with than 9. Does that make sense? Okay. But again, yes, you could pick 9.5 if you really wanted to. I just wouldn't recommend it. So if I plug in 10 squared, what do we get? 100, but it's in the denominator. So I have negative 1 over 100, yes? Now, this will still be positive, but if I cube it, what do we get? 1,000. So is this fraction, my second fraction, 8 over 1,000, going to be bigger or smaller than my first fraction? Smaller. So I have a bigger negative plus a smaller positive. My overall would still be negative. Which is why I said the 10 is kind of helpful, because it's just easy to plug in check. Are we all okay with that?
Yeah.
Yes, no, maybe so.
Yep.
Alright. So now, the first thing we want to check is, do I change signs at each of my critical points? Yeah, because if it doesn't change signs, then it's not a relative min or max. It just is a horizontal tangent, okay? And now the other thing that we have to consider is, right now, I have x equals 0 and x equals 8. So, because we were not differentiable at f prime, at x equals 0, yes? I have to go back to my original function and decide, were we not differentiable because we have an absolute value or like a sharp turn, or were we not differentiable because we were not continuous? So what do we think? Is f of x continuous at x equals 0? So if I plug in 0 here, I'm going to get negative 4 divided by 0, which is undefined at, okay? So we're actually going to have an asymptote there. So it's going to like skip over that. So I can still change from decreasing to increasing, right? But that's not going to be a relative min or max. That's going to be an asymptote, okay? So we don't actually end up caring about that one. So I still have to include it on my table, so that way I know like what my intervals need to be. But I would not include it on my actual answer because it's not going to be a relative experiment. Now, for 8, it is defined, so we're good. And we are switching from increasing to decreasing, which means it's going to be a what?
Maximum.
What kind?
A relative.
Relative. What would I have to apply if I wanted to know my absolute maximum?
Relative. Those are the C.
Those are the C, the candidates test. Right? Then I would have to make a table and plug into my original function instead. But it only asks us about a relative extrema, so we don't have to worry about that. What questions do we have there? So far so good? Alright. I think we have one last one. It's our favorite kind, right? Next to trig equations, right? This is our other favorite kind, is word problems. That's why we practice them, because it makes us better at them. Alright, so it says, coughing forces the trachea to contract, which affects the velocity v of the air passing through. The velocity of the air during coughing is given by that function, where k is constant, r is the normal radius of the trachea, and r is the radius string. That's not the right formula. What radius will produce the maximum air velocity? Let me find the right equation. That didn't copyright.
That's pretty close.
Very slightly off.
It's fine.
Gotta love all the K's and R's inside that.
I know, right?
Brendan, that looks like a T.
I think it's 4.
No, that's can't.
Well, I can't remember if
Like,
I
combine them,
might have just gone ahead and plugged in your K's and R's for you so you didn't have to.